Okay, we're going to start working through this review, and one thing you're going to find handy is having the correct staplet. So on this screen I have two tabs. I actually have two windows, so you can see that. And I'm going to open the normal distribution staplet. So when you go to the staplet home, there it is, normal distributions. And just for right now, I'm going to put a mean of 0 and a standard deviation of 1, because that shows us the standardized normal distribution, the one we typically see. So it says describe a normal probability distribution. It's not uniform. Uniform would mean flat. It is definitely symmetric around the mean. In this case, I put a mean of 0. If I put a mean of 2 for some reason, you can see it's still symmetric around the mean. So I'm going to put that back to 0. So symmetric. Mean, median, and mode are all equivalent. Yes, the median is the halfway point and the mode is the highest point. And those are all the same. It is not bimodal. It doesn't have two peaks. It's not skewed. And most of the data does fall within 3 standard deviations for the mean. I'm going to say no on the model's discrete random variables. I mean, it can if your size is big enough. It is bell-shaped, so this is the only one I'm not sure about. You could say that, but usually it's not for discrete. It's really continuous, so I'm fairly certain that that's going to come back as exactly right. So the point here is, if you have enough of trials, this can start to look like that normal distribution, but discrete usually means that there are gaps, whereas this is a continuous distribution. I can put any decimal I want right there and it's fine. Okay, so there's no values there that are out of bounds per se. Okay, according to the empirical rule, what percentage of the area under a normal distribution lies within 1 standard deviation? So it's just basically having you type in, so we got 95 and 99.7. So this is something that should be on your 3x5 card, okay? We'll hit submit. And if you forgot it, here's how you could find it. On the right side here, I could say, oh, 1 standard deviation means -1 to 1. Now this is going to give you a more precise value. See, it's not exactly the 0.68%, but it's close. Oh, by the way, you can also adjust your preferences here to say percentages if you want to. And let me scroll down and say done. I like my decimals though. Given that x is a normal variable with mean mu equals 46, so I'm going to put 46 over here, and standard deviation 6.2. Oops, 6.2. Plot the distribution. What is the probability it is less than 60? So that would be to the left. Put in 60, calculate area, and go 4 decimal places. So I'm going to not change that to percent. I'm going to put 0.988. You probably are going, well, it says 4. Well, I'll put a 0. Greater than 50. So let me put, that was less than or equal to 60. Don't worry about less than or equal. On a continuous distribution, those are pretty much the same thing. So to the right of a value, calculate area, point. See, now it's giving me more decimals because it's not ending up in a 0. And then between 50 and 60, between 2 values. Now, I could probably guess, well, we'll just do it in. This is easy enough. Between 50 and 60. And I get 0.2474. So we'll submit those. And voila. So super easy. You just put in your mean. So I'm starting problem 4. 109 and 10. So I put those in, plot my new distribution. Oh, 109. Can't type. 109 and 10. There we go. All right, so less than 120 to the left of the value, 120. Calculate. Oh, there's my z-score. Don't mix up your z-score with your decimal. Remember, a percentage or probability should always be less than 1 and at least 0. All right, some of these z-scores you can actually have a negative. So here I want to the right of 80. So that z-score will be negative, by the way. See, it's negative 2.9. And I get 0.999811, which makes sense. I mean, You can see 80's right about here. It's almost all the data, and we want greater than, so most of the data is greater than. And then we want between two values. So we want between 108 and 117. So that's sort of center and to the right, just that little piece right there. And we're going to say 0.328. All right. We'll hit submit. And then the next question we're dealing with is actually going to be a different part of our thing. So we want to find Z such that 13% of the area lies to the right of Z. If they want you to find Z, that means you really want to have the 0, 1 distribution. That's what you want, okay? So make a note. If you're trying to find Z, change that to 0 and 1. Now, we know the area is 13% to the right, so we're not trying to find the area. We're trying to find a value, in this case, a Z-score. So we're going to say to the right, and I'm going to put 0.13. Now, by the way, you'll notice that I have red scores here, so you are going to have to adjust and put whatever number you're getting in. Instead of 13%, you might have 15%. I don't know what your value could be. So my value is 1.126, which, by the way, when you're taking your test, it's going to be randomized as well, so you won't know. All right. I'll go ahead and do this one too. Okay. Find Z such that 63% of the normal curve lies between negative Z and Z. So for that one, you want a between, a central area. So it automatically does central. And I'll change that to 0.63. Calculate values. Now you'll see it's got a negative and a positive. All right. Here, the WebAssign is just looking for the positive value. So don't worry about putting the negative on there. It's going to be the first one you see because it's right there. But this value is good enough to answer this question. So I'll submit both of those. And voila, you can see they're both right. Okay, now we have a customer service center, has a mean of 9.1. Put the 9.1 in, and I'm trying to find probabilities. So I definitely will, let me put in my values first, 9.1 and 2.1. You're going to have different numbers than me. So I could use this exact same question on your test, and it's still going to be different numbers. What will be the same is less than 10 minutes probably. So let's say we go less than to the left of 10. So you can see there's the 9.1 in the center, and so we're going from here to the left. And I get 0.65, 0.6659. And then longer than 5 minutes, I want to the right. And that will be 0.9746. Don't mix it up with the Z-score. I almost did. And then between 8 and 15, between two values, 8, 15. And we get, don't mix, I was looking at that Z-score again, it's 0.6973. And they're all areas, which is what you want for probability, so we're doing well here. Submit for testing. Okay, now we are dealing with another one. Okay, this is a tricky one, so let's pay attention. Future Electronics makes compact disc players. Its research department found that the life of the laser beam is normally distributed, which means we're using this puppy over here. I'm going to put in a mean of 4,900 and a standard deviation of 410. And then plot distribution. All right. Find the probability the laser beam device will wear out in 5,000 hours or less. So this is the life, and so I'm looking at 5,000 or less. So I'm going to say to the left of, calculate area, and it looks like it's 0.5963. Okay, now they want to place a guarantee on the players so that no more than 9% fail. So they're giving you a percentage. Notice we're going to round to the nearest hour, by the way. They're giving you a percentage right here, right? So that means that you're going to basically calculate a value. We already know the area, it's 9%. So I'm going to say 0.09. And no more than 9% fail during the guarantee period. So the thing is, which end do we want? Do we want the central Are we worried about the middle, the average life ones? Or are we worried about the ones that die really early or the ones that live extra long? We're worried about the ones that die really early. So I'm going to put left tail and calculate those values. So it's giving me 4350. I'll try that. Might be 4351, but well, let's try it. So 4350, and then let me go ahead and hit calculate, submit for testing. And voila. So on this bottom one, make sure that you realize they're worried about the ones that die early. So they don't want too many. These are the ones they're willing to cover the cost of. They don't want to cover the cost of all of these, right? Or the middle ones. They want to cover the cost of the ones that just die early. And they only want to have to worry about 9% of them. So they're going to set their guarantee for 4350. Next question. Delivery time for packages is 14 hours. Wow, they're pretty fast. Must be, it's a courier service. I guess they run around on their bicycles and things, or motorcycles. And I'm going to hit plot distribution. What is the probability it will be delivered in 18 hours or less? We're calculating, I don't want a value. I want an area because I want a probability. And notice it says 4 decimal places. You might want to make sure that you set your setting here so that rounding the numbers, I could say 4 right there. So when I do that, you'll see what happens. So I want 18 hours or less. So you might want to make sure your staplet's set at 4 decimal places just to be good. 0.9772. What should be the guaranteed delivery time on all packages in order to be 95% sure the package will be delivered before this time? So that means do we want like capturing most of it at a certain time, or do we want to do a low cutoff? So this is the tricky part on this problem. So if I set a delivery guarantee of 12 hours, you can say, there's a bunch that I'm going to have to refund, right? So it's probably going to be close to this 18. So I need to calculate a value, and I want to cover only the ones that take extra long, and that would be on the right. So the ones that take extra long, that 5%, that's to the right, all right? So that means 95% of our packages, or I could say I want to make sure that 95% of our packages, so first of all, the value is 17.28, 1 decimal place, so I would say 17.3. I can also do this as saying, hey, I want to make sure 95% of my packages come in on this time. And you can see it's still the 17.3. So there are 2 different ways to look at that problem. So these part B's on here, you need to make sure that you're setting your times so they make sense. So in a sense, if you set your time for 10, let's say you accidentally said right tail on this one, right? And you're like, my delivery time, I'm going to say it's close to 10.7 hours. But most of your packages on average are more than 14 hours. So that doesn't make sense. So you want that, if you talk yourself through what makes sense, then you get the better answer. That's a good way to double check this. Submit. We're not that far from done. I know it looks like a long review, doesn't it? But it's not that bad. Okay. See some of those? There's lots of questions in there. Okay. A z-score of -2 indicates a position in the distribution that is definitely below, and it's not 2 points, it's 2 standard deviations. Hopefully that's on your quiz, a test. For a population with a mean of 80, so I'm going to jump in here, put an 80, and put a 12. What is the z-score corresponding to x equals 92? So that, I'm going to jump to area, and you're probably going, but wait, Mrs. Overman, I need a z-score. Watch this. So I'm putting in a value. I have a value. It's 92. All right. Now, it doesn't matter if I'm doing left or right. Guess what? It gives me a z-score. Isn't that cool? The other way you could do it is you could use that formula, z equals value minus mean divided by standard deviation. But the staplet, if you are doing this, the top drop down, you have your mean and your standard deviation, you put your value in there. It doesn't matter if you do left or right. We were just looking for that, which was our z-score of 1. So again, that would have been, if I was doing a calculator, let's see. I would have said, oh, that is my value, which is 92, minus my mean, which is 80, divided by 12. And I hit enter, and it gives me a calculator, and there it is. It's 1. What is the z-score corresponding to x equals 1? I'll do the calculator again. So let's see now. It's going to be the value is 71 minus 80. Close your parentheses, then divide by your standard deviation. In this case, it's 12. And I get negative 0.75. Now, let me show you with the stafflet. So I just put in 71. And I get negative 0.75. So that's a nice shortcut to calculate your z-scores. For a mean of 100 and a sigma of 20, what is the value corresponding to a z of 0.25? Now, this is one where I'm actually going to have to pause and do a CAMI. So actually, let's see. I think I can do a CAMI right here. Blank sheet. This is one of the times that you really want to just do a formula. So I'm going to say, I'm just going to use a text box. So I'm going to say, okay, z equals, right? And that's going to be value. In this case, my value is x minus my mean. My mean is 100 divided by 20. All right. Oh, and I know my z-score. Actually, let me retype this. Retype this. So this is the general formula. You want this on your chart. All right. So now I'm going to substitute. I have 0.25 equals. Oh, and here's actually an easier formula. So here's the other formula you want. I do give you this formula. So take your z times your standard deviation and add it to your mean. So you don't have to do the messy algebra. I rearranged it for you. So we want that second formula. So x equals 0.25 times, this is probably a little small for you, isn't it? Let's bump it up. Let's go 18. There we go. So x equals 0.25 times the sigma, which is 20. Remember sigma, that funny symbol on the left there, that's just another way of standard deviation. And then plus 100. Well, that's x equals 4 plus, oh wait, let's see, is that right? 5, not 4. Plus 100 equals 105. So it's 105. All right, let's do it again. What is its x value corresponding to z equals negative 0.5? Now, why aren't I doing the staplet for these, right? Let's see, maybe we could. Well, if I go to my normal distribution and I put in 100 and I put in 20, right? And I plot the distribution, and I could put my value in. Let's see if it does it. Oh, no, it doesn't. So I'm trying to find the value. I can put in my z-score, but I can't put in my value. So we'll go back to our formula. Okay, so this is part 2, number 14 on review, right? And this one was number 13 on the review. Okay. So in this case, x equals, it's still the same, oh, different z-score. Negative 0.5 times 20 plus 100. So x equals negative 10 plus 100, which is 90. So I'm going to pick 90 as my answer right there, and we'll go ahead and submit both of those. Okay, so you can see we got them both right, as we should. For the past 20 years, the high temperature on April 15th has an average of 62 and a standard deviation of 4. So I just feel like, oh, I probably want to put that in here. I don't know if I'm going to need this, 62 and 4, and plot my distribution. Might as well. There it is. It's all beautiful. Last year, the high temperature was 72 degrees. Based on information, which of the following best describes last year's temperature? Well, let's put in 72 and see how unusual that is. Let's do to the right. Oh, it's in the top 99%. So if I did to the right, less than 1% above it. So I was going to say it's more than 2 standard deviations, and it's more than 2 standard deviations above, it's pretty high, so we consider that unusual. Okay. Did I need the staplet? Probably not. I could have just calculated the z-score. It gave it to me right there. It's 2.5. So I could have plugged it back in that CAMI right here in that formula where it finds z. Okay. So let's go back here. I'll submit. Okay. So there we go. Far above average. If in N equals 25 games, last season the college basketball team averaged a mean of 78, so I'm going to put 78 in, and a standard deviation of 12. In their final game, the team scored 89 points. Based on this information, all right, so plot distribution, 89, it's a little above average. I don't even have to calculate a z-score, but if I wanted to, I'd just put 89. And you can see it's in the top 18%. It's not that great. It's a little above average. All right, a little above average. Submit for testing. Okay, let's go to these next two. A very bright student is described as having an IQ that is 3 standard deviations above the mean. If this student's IQ is reported as a z-score, the z-score would be which of the following? So the z-score is just how many standard deviations above the mean? It's just 3. That's it. What is the z-score corresponding to the mean? It is 0. Have that memorized. So remember this curve where you have the 0 and the 1? That is in z-scores. That's a normal distribution in z-scores. And the mean is 0. Okay, for a population with mu equals 70, the mean is 70, and the sigma is 20. Find the z-score that corresponds to each of the following values. Well, we can, what is this, number 19? Number 19. We could use z equals, in this case, 80 minus 70 divided by 20, which is 10 over 20, or 0.5, right? And voila, I will put 0.5 in. Or we could, because you guys are allowed to use a staplet, 70, 20, and I put in 80. Calculate. I don't care which side. I'm just trying to get this thing, 0.5. Oh, let's put in 100, because it's giving me z-scores automatically. 1.5. Let's put in 65. Negative 0.25, does that make sense? Yes, because it's below average. And then this one should be really negative 40. So it's going to be not all the way to negative 3. It's like negative 1.5, right? Yep. Oh, it is exactly negative 1.5. So negative 1.5. And then submit. See how fast that was? Super fast. As long as you understand what x's and z-scores are, I'm fine with you letting, this is just algebra right here. Okay. So for a population with a mean of 62 and a standard deviation of 12, so this is what it looks like. So a z-score of negative 0.25, so it's going to be somewhere in here. Sadly, this is where I need to do the formulas. So I have to really, let's jump down. We're going to do number 20. Number 20. So we have x equals negative 0.25 times 12 plus 62. So I just got to, grin and bear it and do the math. So it's negative 3 plus 62. I'm doing that right, which is 59. So that's the first one. So I'm saying that's at 59. Does that jive with my graph? Let's look. Yeah, 59. That's probably about a quarter of a z-score down. All right. Ooh, negative 1.5. Let's just do it. X equals negative 1.5 times 12 plus 62. So negative 1.5 times 12 is negative 18. I presume you might want a calculator handy when you're doing these. I'm doing this mentally because I coach mental math. But guess what? I can still make mistakes on these too. So, let's see, I'm getting 44. That's what I'm getting. We'll see if I did that right. 0.5. So let's do 0.5. This one's a little easier because half of 12 is 6 plus 62. That's pretty easy, 68. And then 2 standard deviations above the mean. So I would just take 24 plus, here, I'll do it. So 2 12s, which is 24, plus my 62. 86. So these right here, you definitely need to get a calculator or a scratch piece of paper. If you created your cheat sheet, you can go ahead and show your work on your cheat sheet. That's always good. Did I miss anything? No, I thought I saw an X for a second. And they are all correct. What proportion of the normal distribution is located in the tail beyond a z-score of z equals 1? So let's go ahead. It's talking z-scores, right? So we automatically want 0 and 1. 0 and 1. And they said, okay, we want it to the right of this. Now, I could use empirical rule, or I could just say to the right of 1. Why do I want to the right and not to the left? Is because they're saying beyond. So that means far away from the center. And I'm getting 0.1587, which, if you recall from our empirical rule, we had 34% in here. So that makes sense that we have about 16% there. In the tail of a z-score beyond -1, I'm going to say the same thing. Okay, why am I saying that? So first of all, if I put -1, right, why am I saying it's the same thing? You're probably going, wait, it's 84%. Well, beyond means away from. So I really want to be away from the center. So I want to be over here. And it's 15%. It's not ever going to be negative just because it's on the negative side. Okay. A vertical like is drawn through a, I'm sure that's a typo. And that's not even my question. That's so funny. It's drawn through a normal distribution at z equals point. They probably, a line. A vertical line is drawn through at z equals 0.25. Separates the distribution into 2 sections. What proportion of the distribution is in the smaller section? So I'm going to do 1. And so this is, it automatically did to the left. Is that the smaller section? No, the one to the right is the smaller section. So let's click to the right, calculate. So that's that 15.87. Oh, I did it at 1. Helps if I put this thing in the right spot. Let's calculate area. Okay, I have 40% here. If I did to the left, I would have 59%. So you can see the smaller one. And it probably makes sense. It's to the right because it's above average. So this is a smaller piece. So I'm going to go for 40.13%. Okay, now we're going to do it at -1. What is the larger section? All right. I left it to the right, 84%. I'm pretty sure that's the larger section. What is the probability of randomly selecting a z-score greater than 0.25? So bigger than 0.25. So we just calculate the area. It's the same thing we've been working with. Ooh, they're very fond of this 40% here. What is the probability of randomly selecting a z-score less than, so to the left, of -0.8? And you hit calculate. It's 21.19%. And wow, are we almost done? Tell you what, let me go ahead and submit what we got so far. We're almost done. Make sure I didn't have any typos. Just check, check, check. Again, remember, some of these you can probably copy straight off of me. Don't recommend it. I recommend you understand it. But a lot of your tests will have randomized numbers. In fact, I wouldn't expect to see a lot of these on there. What z-score value separates the highest 40%? Oh, it's a good thing I took a break right there. Because now the questions changed. Here they were giving me a z, right? Now they're giving me a percent or an area, and they want me to find a z. So they want me to find a value. So there's the value. And we want the highest 40%. That means I want 40% of the area to the right. 0.4, calculate, and I get 0.2533. Don't worry that it's like there's a 33 here and it's 0.25 there. That's fine, it's close enough. And, well, it's also multiple choice, so there you go. And it's definitely not negative, it's on the right side of the mean. The highest 90% separates from the, so the highest 90%, so make sure I do 0.9, is on the high end. So that's the highest 90%, this is the lowest 10%, and you can see my z-score is negative 1.28. What proportion is located between, oh, so now we want an area. So first of all, let's double check these because we were finding z's, and now we're back to areas. While it's doing that, I'll change this to area. Wait, I'm finding calculated area. And we're on the last two. And it's only about 30 minutes. What proportion is located between z equals 1 and 1.5? So we want between two values. 1, 1.5. Calculate area. And it looks like it's 0.0918. Close enough. Don't worry, don't freak out too much. All right. Then I have negative 1.16 and positive 1.16. Notice we didn't have any outside of two values. Not sure who's calling. And then calculate the area, and I get 0.754. Hit submit for testing. And I should have them all correct. Voila, and that is the end of your review. Again, several of these have different numbers, so be prepared to have to generate different answers for that. And if you have questions, come in during Flex or ask me after our lesson in class.